All right, ladies and gentlemen, welcome back to another riveting lesson in geometry. We are talking about volumes of prisms and cylinders. Title your notes, 12.1. Okay, and let's see, 12.1, volumes of prisms and cylinders. So the volume of a prism is pretty easy to find. You have to find B times H, which B stands for area of the base. All right, so this is important, that B is the area of the base. Okay, and this gets confusing. So notice that we're using a capital letter here. A capital letter usually indicates that some kind of operation has happened, like multiplication in this case, whereas the lowercase often indicates that that's just the number by itself, like the side or a line, or in this case the height. Notice that height always has to be at a right angle. So if you have a right prism, then you can use any of the sides as the height, but if you don't have a right prism, you do need the right angle. Okay, for a volume of a cylinder, we have the same thing, base times height, but a cylinder always has a circle as a base, so instead of B, we can also just write pi r squared for the volume of a cylinder. All right, here's an example finding volumes of prisms. So remember, volume is base times height. Where are we? There we are. Volume. Volume is base times height. Okay, so here, what's the base? This is a triangular prism, so the base is one of the triangles, and here's the right angle. So the base and height, we have to find the area of the base first and then multiply it by the height. So 2 is going to be the height of the prism. So the area of the triangle is 1/2 times 3 times 4. That's base times height for a triangle, so this gets confusing because we've got base times height for the volume, but that's area of the base. Base times height for the triangle, that's just base and height, those sides, times the 2 for the height. That's the volume, and that gives me a volume of 6 times 2, which is a total of 12. Now for this one, we have a trapezoid as a base, so we have to find the area of the trapezoid. That is 1/2 the average of the bases. That's the average of the bases times the height. So 1/2 base 1 plus base 2. 1/2 base 1 is 6. 6 plus, and base 2 is 14. Half of the average of the bases times the height of the trapezoid, and that's 3. Times 3, this right here is the area of the base, times the height, times 5 is the height of the prism. So the volume here, 6 plus 14 is 20, half of that is 10, times 3 is 30, times 5 is 150. Alright. For a cylinder, we do pi r squared to find the area of the base, and then multiply that by the height. So the volume is pi r squared times the height, which in this case would be pi, times 9 squared times 6, and that gives me approximately 486. Well, it gives me exactly 486 pi, or approximately 1,526.81. Right, in this case, we're using this as the height because we always need the right angle. Very important. So here we have volume is pi r squared, 4 squared, times 7, and that is 112 pi, or approximately 351.86. Sorry, that's an ugly 6. There we go. All right. We can use volume. We can apply that and to help us find density. Okay, density is found by taking the mass of an object. Mass is usually something we call the weight, and we divide that by the volume. So mass is a measure we use for weight, and we can find here the density of this gold bar. Okay, so a standard gold bar. We want to find the mass in this case. We know the density, we want to find the mass. Okay, so we can find the volume here. Now this is tricky because this is in grams. Alright, so we have to convert to metric, which is always a good time. Conversion from inches to centimeters. Inches, 1 inch is approximately 2.54 centimeters. So we can multiply each of these by 2.54. Multiply this times 2.54. And same thing here times 2.54. Alright, so then we get new lengths of, comes to 17.78 centimeters. This is 9.2075 centimeters, and the height is 4.445 centimeters. All right, so what we want to do is we want to find the volume. Volume's just in a rectangular prism, just length times width times height. All right, 17.78 times 9.075 times 4.45. So we're going to multiply. Let's see. I'm going to multiply this times this. That gives me the base, and then I'm going to multiply that times that. All right. So that's the volume. Volume is length times width times height, or base times the height, which comes to, where are we? There we are, 727.69 centimeters cubed. Okay, now I want to take that, and in order to find the density, we have to multiply both sides by volume. Multiply this by V and multiply this by V. Sorry, not in order to find the density, in order to find the mass. I'm solving for this, so I want to cancel out the volume, right? So mass is density times volume. So I'm going to do volume times density, and that will find me the mass. So the mass in this case is the 19.3, sorry, I did it out of order. 19.3 is the density times the volume that we found, 727.69, and that gives us about 14,044 grams is the unit here. Alright, let's look at our next example. If you know the volume, like here we have a wooden chest, you want it to hold this much, okay? And you know you've built the base 6 feet by 4 feet. You want to figure out how tall do you have to make it in order for it to hold a volume of 72 cubic feet. So now if we know the volume, remember volume is base times the height. So if we want to find the height, divide both sides by the base to find the height. So the height is going to be the volume, 72, divided by the base, which is 6 times 4. 6 times 4 is 24. So 72 divided by 24 would give us 3. So we want a height of 3 feet in order to get a volume of 72. All right, if we are building a dresser here and we know that the height is going to be 6 feet, we want to know what area can I make the base. So it has a volume of 36. we want to find a possible length and width. So in order to get 36, I could arrange this rectangle different ways. I do know that volume equals base times the height. So this time I'm trying to find the base, so I'm going to divide both sides by the height. So the base is volume 36 divided by 6. So the base has an area of 6 feet squared. Okay, now how do I get 6? Well, I find some factors. Okay, I could have 6 in 1, or maybe 2 by 3. So the length could be 2, the width could be 3, or the other way around, the length could be 3 feet, and the width could be 2 feet. All right, similar solids. Similar solids is the same type of solid with equal ratios of the corresponding linear measures. Corresponding linear measures, like for example, the radius and the height, or the length and the width. Okay, so if we want to find the volume of a cylinder, oh, sorry, I skipped some important information. If two similar solids have a scale factor of k, and the scale factor is the dimension of one divided by the dimension of the next one, then the ratio of the volumes is equal to that scale factor to the third power. Remember, volume is cubed, right? We take the units cubed, so we're also going to do our scale factor cubed. Okay, this is going to be easy to use. We can figure out what the scale factor is here, and then just cube that scale factor in order to find the new volume. Right, so the scale factor is always new to original. Remember, scale factor is new over original. That's the scale factor, k. All right, so new, here we have 6, original 3. So that's 6 over 3. So the scale factor is 2. Right, I have to multiply 3 by 2 to get 6. So the scale factor cubed, that's 2 cubed, that is 8. 2 times 2 is 4, times 2 is 8. Okay, so I have to take the volume times the scale factor cubed, so that is 45 pi times 8, and that is 360 pi. All right. And finally, we've got one more example to work through, and that's finding the volume of a composite solid. You can do this a couple different ways. You can either find the volume of the large rectangular prism and then subtract 2 of these small rectangular prisms. Subtract the volume, so you could find the volume of the large one and then subtract 2 times the volume of the small one, because these are identical. Or you could find the area of the base and subtract the holes we have here, so, and then just multiply by the height. So we'll do that one. Find the base by taking the area of the large rectangle minus 2 times the area of those smaller rectangles. Okay, so the base is going to be 1.31 times 60.66 minus 2 times 0.33 times 0.39. All right, and this comes out to be a base of 0.6072. And then for volume, we want to take the base. Volume is base times height, so that is 0.6072 times the height of 0.66, and that gives us an approximate volume of 0.4 cubic feet cubed. All right, slightly longer lesson today, but still lots of good times in the matherhood. Woo! Oh, maybe some glasses for him today. Check back again next time for another fun lesson.